Welcome back to Numbers Sense Academy, and in this video we're going to look at solving linear equations with two variables. So basically what we're trying to figure out is what solutions exist for systems of linear equations when we have two unknowns. So that's pretty much what we're trying to figure out. But it's just two unknowns, and we're going to work with just two equations. So even if you have several equations, if you have several equations, we're pretty much going to just pair out the equations. So if the best situation that you could have is if you have several of these lines, we could try to find a feasible region. But as far as more than two equations interacting to say intersecting at one point or forming some type of plane, we're not doing that. It's just in the Cartesian plane. So these equations, they're lines that exist in the two-dimensional space of the Cartesian plane. So essentially what we're doing is graphically we are looking for the point of intersection between the two lines. So wherever they cross, we say that's the solution. Okay, so the point where they intersect, I should highlight this whole thing. This is the solution. Okay, and it's going to be a solution that has x, y values. So some value of x, some value of y. Okay, so if it's a solution and if it intersect, that means the point is common to both equations. So that means that that point lies on both lines. Okay, so we're just saying the same stuff, just in different ways, just so we have a full scale understanding of what that means to have a solution to a system. So there are three types of solutions. Okay, so the first solution is that you end up with a unique solution. So the system has a unique solution. Okay, if that's the case, then so if this is true, if it has a unique solution, then the system is consistent and independent. Okay, and back to further to what I just said, they share a common point. All right. Second point, or the second type of solution that you could end up with, is no solution exists. That means that when you put these two equations on the Cartesian plane, the lines are parallel. So if the lines are parallel, that means they never intersect. If the lines are parallel, then they never intersect. So lines never intersect. So that's no solution exists. Okay, so you can't find a point where these two lines will meet because they never will meet. And then the third outcome is that many solutions exist. So many solutions exist. And this means that the two lines coincide. And this results in infinite solutions. Further, if many solutions exist, then the system is consistent and dependent. So if there's one solution, then the system is consistent and independent. If there's no solution, the system is inconsistent. And if there are many solutions, then the system is consistent and dependent. Okay? So every point on either line is common to both lines. That's what that means. Every point on either line is common to both lines. So let's look at some quick examples before we go. So suppose you have this situation. So I have my y values, my x values. I end up with these two lines. So I have one line going this way, and I have another line going that way. So I have L1 and L2. Well, L1 and L2 meet right here. Whatever this point is, that's where they meet. Okay, we'll call it X star and Y star. So X star and Y star is common to both L1 and L2. All right, this is a unique solution. All right, so this is a unique solution. Should be pretty easy to remember. So if you see a graph that where the two lines meet at one point, they are consistent and independent. Another quick example: what if you have two lines that look like this? Call this L3 and L4. These two lines meet right here. They only meet once, so it's a unique solution. Okay, what if we have a situation that looks like this? Where we have two lines, that one's going. Okay, let's change the color here. One's going that way, the other's going that way. Well, they're both going in the same direction. I'm going to indicate that these lines are parallel. Okay, so L1, L2, where L1 is parallel to L2. That means there's nowhere these two lines are going to intersect together. So there's no solution. There's absolutely no solution here. Okay, so this is an inconsistent system. Right? And then the last possibility you have a situation where you have, I'll draw it this way so it's easier to draw. And then you have another line. I'm trying to draw this as best as I can. So we have the yellow line is L1, the red line is L2. So L1 is exactly L2. They share all the points in common. So this has infinite solutions. Okay, so whatever point is on L1 is also on L2. And this is consistent and it's dependent. Okay, so those are the three situations that we have with systems of linear equations. We either have one solution, no solutions at all, or many solutions. All right, that's it and that's all.